less than 10 seconds.
Hey everyone, Michael Unger here at the H.R. McMillan Space Center for our bonus interview for our Cosmic Night Exoplanets. And I'm really pleased to be joined with someone all the way across the other side of the country. This is the cool part of doing all of our programs online, as we get to connect with brand new people in other provinces. And we're going to be speaking with Frédérique Béron. She is the Scientific and Education Public Outreach Coordinator at the Exoplanets Research Institute at the Université de Montréal. And she specializes in the research of gas giant planets on wide separations using the direct imaging method. This is really cool stuff. How are you, Frédérique?
I'm good, and you?
Yeah, wonderful. So tell us a bit about yourself and your research and what you do at the Exoplanets Research Institute.
So I'm an astrophysicist. I got my PhD at Université de Montréal last year. So it's been over a year now. Times fly by. And what I do is mostly outreach. Okay. So I love to talk to people. So that's mostly my job, talking to people. But as an astrophysicist, I got to go to the biggest telescope. Like here you have a picture of me. It's a selfie. And in the background you see the Gemini telescope. I'm here like on the catwalk of the CFHT telescope. And my data for my PhD was taken at CFHT. So it was really great to get to go and to see the telescope itself. And I also do a lot of outreach, so it means that I get to play with toys like this sun here. I have a really nice sun in my hand. I really love those soft toys. And a soft spot in my heart is the Observatoire du Mont Mégantic. In Quebec, we have a 1.6 meter telescope that we can use for scientific purposes. And it's really, really dear to my heart.
Oh, wonderful. That's the one that's just outside of Sherbrooke, right?
Yes, it's about a 3-hour drive from Montreal, where I live, and where at the university I work at the University of Montreal. And it's really a nice spot to look at the sky, because it's in a dark sky reserve, which means that the quality of the sky is really great. So there's little light pollution.
Wonderful. So let's get into your exoplanet research. And you specialize in gas giants. And of course, we have gas giants in our solar system, Jupiter and Saturn, but you're talking about exo gas giants. Could you tell us a bit about what these planets are?
Sure. So we all know Jupiter. Jupiter is my favorite planet in the solar system. Jupiter is it's a big planet. It has rings too, even though we don't usually talk about them. We talk about Saturn rings, but I would say that Jupiter is prettier than Saturn. Mm-hmm. I know it's a big debate. It's the biggest one. It's a gas giant, and it is about 5 times. It's about 5 times farther away than the Earth from the Sun. So it's at 5 astronomical units, and the Earth is at 1 astronomical unit from the Sun. So it's farther away. It's at a normal distance. It's at a distance that we would expect, because Jupiter is at a Jupiter distance from the Sun. That's what we expect. But I think you've learned a bit about exoplanets in the event that happened today. Yeah. So you know that the first exoplanet that was discovered around a sun-like star, well, a main sequence star, is a 51 Pegasi b. 51 Pegasi b, it's a Jupiter-like planet, so it's about the mass of Jupiter, but it's super close to its host star. It's so close that those kinds of exoplanets, we call them hot Jupiter. It's a really good name. It's a Jupiter, and it's hot, so it's a hot Jupiter. I mean, in astronomy, we don't always have good names for things in the sky.
Yeah, it's a good band name as well.
Hot Jupiter, there's a few band names. If you think about planet, what is that? There's no planet. I mean, it's what we have after a star has died, but there's no planet there.
Just say that
hot Jupiter.
Just say that word again. I think like Zoom just cut out there. We just missed the word that you just said. The second
planetary nebula.
Oh, there you go. Yeah.
Yeah. So in the planetary nebula, there's no planet. but it's
Okay.
still called planetary because it's roughly round.
Right.
But a hot Jupiter, it's hot and it's about the same mass as Jupiter, so that works. And those kind of planets, they're fairly easy to find because they're really big and they're really close to their stars.
Okay. So, and you use the direct imaging method to find these planets. Could you tell us a little bit about how that works? Like, are you talking about you just use the telescope and you're just finding these planets? Like, they don't give off light; they're so far away. How is this possible?
Yeah, so those are hot Jupiter, but the kind of planet that I really like, they are the planets that are widely separated, so really far away from the star. So you have one here, GU-PSCB here. That planet is 2,000 astronomical unit from its host star. So 2,000 times farther away than the Earth is from the sun. That's really, really far. When you're so far, you don't reflect light. So Jupiter is bright because it reflects light from the sun, but a planet that is so far away, it doesn't reflect light. So you have two ways to find exoplanet. And what I did during my PhD was to look for those kind of exoplanets around young star. Because when a star is young, its planet will also be young, and a young Jupiter-like planet is much brighter than an old Jupiter-like planet. Still not so bright, but brighter than an old one. So that's what I did in my PhD, trying to look for those widely separated Jupiter-like planets. It's really, we call it direct imaging, but it's really non-fancy direct imaging. It's really like just taking a picture, stacking the images, and trying to find something that is really, really faint in a picture.
Right. And so I guess what the interesting thing is, thinking about these exogas giants, is we always want to compare them, and you always have that, and you have that name, hot Jupiter. So we have Jupiter and Saturn, and we know these planets, but so are these planets that we're finding, are they like Jupiter and Saturn? Are they common? Do solar systems have Jupiter and Saturn? Is that a common attribute to these planetary systems?
So Jupiter at the distance of Jupiter, this is the kind of planet that we expect in a given solar system. Jupiter is like a bit far from its star to be able to really discover it easily. Mm-hmm. But we do discover objects that are either the mass of Jupiter or its size, its radius. And if we're lucky, we have both. And then we know it's really like a big puffy ball of gas. Saturn is about the same density. Well, Saturn all know it can float in a bathtub. It's really not so dense, but it's still pretty big. It's still like pretty big for a planet. So the closer in they are from their stars, the easier it is to find, but not with the direct imaging method. Because with the direct imaging method, you want to have the planet farther away because the star is so bright. Like look here. Here, this is a picture of HR 8799. So this is the planetary system that was discovered in 2008 by a Canadian team. And here you have 4 planets. Can you see them?
No.
Okay, so I will help you. So what we do when we want to find those big Jupiter-like planet on pretty wide orbits, one thing that we can do is to put a coronagraph. So coronagraph is like a mask. It's the same thing that, you're driving and you see the sun, it's blinding you. So you put your hand so that you can see the road. Mm-hmm. So that's the coronagraph. So I will do that here. We'll do that now. And there you go.
Okay.
So I've hidden the star.
Yeah.
So it means that I cannot see, the dark part here, I cannot see what's underneath. So mm-hmm. Maybe there are planets, maybe there's a Jupiter, like really Jupiter at the distance of Jupiter, really closer in, but I cannot see them. But when I do that, I can see 4 planets. So there's one here, 2, 3, and 4. And even more amazing, I think this is the prettiest picture of astronomy right here. Here you see the 4 planets around HR over a period of about 8 years. And you see them, they're turning around. They're going around the star. They are gravitationally bound to the host star. Yeah. That's pretty amazing. So we know they're not just a dot, or a star that's in the background. We know those planets are really linked. They're bound to their host star. And exoplanets that we can see, we know only of about 20. And there are about 4,000 exoplanets that we know, but we can only see 20 of them. So that's pretty unique.
I love how you said this is one of like the prettiest space pictures, and I think that's
It is.
such a wonderful scientist answer, because now that you've explained it to me, yeah, it is really wonderful. And I think this is the beauty of astronomy, is that what this picture means. Once you find out what it means, it really does become really beautiful, because we're looking at an alien solar system. That is so cool. So, what have you been able to learn about these systems? And are these solar systems that might be compatible for life?
Well, these systems, they're just, the planets are really too far away. Well, first of all, here we're talking about Jupiter-like planet. Jupiter has no surface. We cannot walk on a Jupiter-like planet, even our Jupiter. There's no place where we can walk. So for life, that's not really good. When we think about life and gas giant, we think about life on their moons. So life on the moons of Jupiter or Saturn, that's something that is really being investigated in our own solar system. Exomoons, so moons around exoplanets, yes, we call them exomoons.
Oh, wow.
And we also have exorings, for the rings around exoplanets. I don't know where it will stop. I think it will never stop, the exo thing. But exomoons, at the moment, we know of maybe one, maybe two. None have been confirmed. So when we think about life, exomoon is still like way out of the picture. And life on an exo gas giant, well, life on a gas giant, that's not possible. So here, searching for widely separated gas giant, it's not about searching for life. It's about knowing how a solar system forms. It's about really the fundamental of how you can build a solar system. Well, an alien system really here.
Yeah. Okay. So we in our previous Cosmic Night, we actually talked with Natalie Ouellette, and she's on the team the outreach team for the James Webb Telescope. We're hotly anticipating this telescope to go up. When it finally does go online, how is this telescope going to help your research?
James Webb. I think it will solve like all the problem of astronomy in all fields. I think like every talks always end with James Webb will do that.
Yeah.
For gas giant on wide orbits, it will be mostly about trying to reach the gap. With the radial velocity method and the transit method, we cannot find object Jupiter-like planet that are moderately separated from their host star. And with the direct imaging method, we can only find the widest. So there's the closest that we can find easily, and then the widest that we can find with the direct imaging method. And there's like a gap in between. And that's because of the coronagraph. We cannot see inside of the mask that we put. But with James Webb, we'll be able to squeeze and to go and work that inner angle a bit more and to find objects that are closer in. So that's something that's going to be really interesting, especially if you combine with the ALMA images, for example, of disk, where maybe there's a planet, but we cannot see them. James Webb won't be about looking at a big patch of sky and trying to find new things. It will be mostly about follow-up, trying to maybe look at the planet of HR 8799 and have a better spectrum of all of those planets to really know what they're made of. But it won't be about like discovering really like a whole lot of new planets, because it's too expensive, right. Observationally.
Right. So there will be other telescopes that will be doing the work to find these planets. And then once they find some really good candidates to probe deeper, to look at the atmospheres, that's where James Webb's going to come in to kind of get the slam dunk.
Yeah. All of these planets here, they will be observed by James Webb, I'm sure.
Oh, wonderful. Well, thank you so much, Frédéric. We are going to end this off with a question that we're asking everyone during our event, which is, what is your favorite exoplanet?
Okay, so my favorite exoplanet, it's this one. It's JG 504 B. Why? Why is this my favorite exoplanet, JG 404? It's because it's actually maybe not an exoplanet. My favorite exoplanets, they're the exoplanets that are at the limit of being a brown dwarf.
Right.
So to be an exoplanet, you have to be light. You have to be less than 13 Jupiter mass. 13 Jupiter mass, that's where the deuterium will start to fuse inside the core of an object. But something like that, and so it's the case of most exoplanets that have been directly imaged. The mass that we have for those objects is about like 12 plus or minus 4. So they might be an exoplanet, but they also might be a brown dwarf. And I really like brown dwarf. Yeah. And this one, it might be pink, so that would be nice. This is not an actual image. This is really a drawing, an artistic rendition. But I really think that those objects are really fascinating because we're not sure what they are. We don't know what's their nature.
Could be a star, could be a planet, could be pink. I'm just getting feeling so relatable right now to this planet. If you were to name this planet, do you have a name picked out? If you could name JG 504b, Exobaron, maybe.
That's funny because we really don't name exoplanets, but we do name binary system with our name. So in my master's, I found new binary system. So when you have like a star bound to another star and they both like go around each other, and I found a bunch. So I have a bunch of binary system named to my name. But for planets, it's weird.
Awesome. Well, Frédérique, thank you so much for taking time to talk with us today. And hopefully you make more of these discoveries in the future.
Thank you.
Awesome. Thanks, Frédérique.
10 seconds.